Welcome back to our second part of the measurement topic. So I hope you enjoyed the area one. So if you have enjoyed and you haven't subscribed, please subscribe. So let's go on to volumes and total surface areas. So we are starting to deal with a rectangular prism, triangular prism, and a sphere face. Then we can deal with the pyramids and a cone in the next chapter. So let's see. So if you're trying to find the volume of a shape, or before I can go there, what is the volume? So the volume is the total space inside a 3D shape. So it's more about how much we can fill inside a 3D shape. Just like this shape, you can see I'm not a good drawer, but you can see that there is a space inside, right? There's a space inside. So the volume is how much you can fill inside that shape. So finding the volume of a triangular prism. So we started with the triangular prism. So a triangular prism can also be a square prism as well. So it depends on how it is. But we deal with the rectangular prism and the square prism or a cube in the same way, right? So this is a triangular prism. So finding the volume of a rectangular prism, we just say length times the breadth times the height. So that's how we can find the volume of a rectangular prism. So this being the length, this being the breadth. So the base one is the length and the breadth, and we are also having the height like that. So we measure this in units cubed. So just like if you're having millimeters, it will be millimeter cube. If you're having centimeters, it will be centimeter cube. If you're having meters, it will be meter cubed. If you're having kilometers, it will be kilometer cube, like that. So that's how we can find the volume, how much you can fill inside this shape. So now going to the total surface area of this shape, I need you to understand something. So how many faces do we have of this shape? So let's try maybe to count together. So we are having this front face, this one that is facing me. This one is having the breadth and the height. So it is having this and the height. So what is the surface area or the total surface area? Mostly we are trying to find the exterior, the total exterior area of all the faces that are on this shape. So I said this is the total exterior, surface area of all the faces on a 3D shape. So let's try to find, or how do we find the total surface area of this shape now? So finding the total surface area of this shape won't be hard. So let's see. So how many faces do we have? So if you can check here on this side, we are having this face that is having a breadth and a height. So to find the area, we can find the area of this, right? So we're having a side that is having breadth times height. So if you can check also on the other side, this side now that is having this is also having the breadth, because this is also the breadth and the height. So we're also having another side also that is having a breadth times a height. Can you see that? And if we are checking on this side that is facing us, this side, we can see that this side or this face is having this dimension. So this is having the length and the height. This side that is facing us, this side. So it is the length and the height. So we are also having the face that is having a length and a height. If you can check that other side, we can see that also this side here, it is also having the length, because this is the length, and it is also having the height. So that also has the length and the height. And you can check on the one on top. So the one on top, this is having the length and the breadth. So this is having the length and the breadth, the one on top. So I'm going to have this one that is having the length and the breadth. And this one on top is also similar to the one below. So also to have the length and the breadth. So we can see that we're having two of these, and we're having two of these, and we're having two of these. So it means that to calculate the area, the total surface area of a rectangular prism, we need us to do something like the total surface area will be equals to 2 times the breadth times the height plus 2 times the length times the height, and lastly plus 2 times the length times the breadth. So that's how we can find the total surface area of a rectangular prism. So now you know how to calculate the volume and the total surface area of a rectangular prism. So it means that now we can move to a triangular prism and a sphere. So moving on to the triangular prism. So if you're having a triangular prism, we take this triangle faces as the base. So calculating the volume of this, we can say the volume of a triangular prism is equal to the area of the base and then multiplied by the length of this, or the height. You can say the length of the height. So it means that our volume now becomes what? We know that a volume of a triangle face is equal to half base times the height, which this height is the height between these vertices and this breadth. So this is the height we are talking about. So this is half of this multiplied by this height, and you can multiply that by the length. That is how you can find the area of, the volume of this shape. So finding the volume is not that much difficult of a triangular prism. So the difficult, a bit of a difficult, I can say, starts when we are trying to find the total surface area of this. But don't forget that we say that the total surface area is the total exterior area, right? Surface area of this shape. So it means that we are adding the area of this face facing us, the area of that face facing that way, and the area of this face facing below, and the area of this triangle and the area of this triangle. But these two triangles will be having the same area, right? Because these triangles are equal. So to find the total surface area of this, let's say this. So this is the area of a triangle. So this is the area of the triangle, right? How many are they? There are 2. So it is 2 times the area of the triangle plus, if you can check here, this shape and the shape that is that side. So this shape that is facing me here, let me just show it like this. Can you see that? Which dimensions is this shape having? So we are only having the length, but we are not having this height. But we can find that height. So this is another trick. Just take a look at this, right? So this height, in able to find this height, that you can call the slant height. So that is the slant height. How do we find that height? We can use the theorem of Pythagoras, because we can see that this side is perpendicular to that. So it means that the distance between this point and this point, we can have that, and we can have the distance from only this point to this point. So if we can have the distance from this side to this side and have this to this, it means that now we are having our acute right angled triangle. So it is having this height, this length height, and this half of the base. So to find the slant height, we can say that the slant height squared, so this is the theorem of Pythagoras, would be equals to the height squared plus half of the base squared, and then you can solve for slant height. So just be careful about that. You can note that down. It is very, very important when you are dealing with the total surface areas, right, with the measurements. So I've shown you how to find the slant height. So let's move on. So I said this is the slant height. So if you can check here, we are having this face facing this side, it is having the length and the slant height. And the other one, that side, it will also have the same measurements, the slant height, and the length, this distance, like this. So this is the area of two rectangles that are equal. So the area of triangles times 2 plus the area of two rectangles that are equal plus the area of one other rectangle that is different. So how do we mean that is different? We are having this other rectangle that is below, that is having the measurements of the base, or the dimensions of the base and the length. So according to this, the way I showed you, it means that now our total surface area becomes, right, so this is 2 by half base times height plus 2 by length multiplied by the slant height, and then plus the area of that other shape being length times the breadth. The thing is that you don't have to cram these formulas, just learn to understand them. When you understand them, you can be able to use them no matter the situation that you can be having, right? So that is the formula that you can use to find, or this is the way that you can use to find the total surface area of a triangular prism. So it means that let's move to a sphere now. Lastly, let's get to a sphere and a hemisphere, right? So to calculate the volume of a sphere, all we need to do is to say 4/3 of pi r cubed. So this is the radius from the circumference of the sphere to the inner center, right? That is how you can find the volume of that. But having a hemisphere, it means that it is just half of the sphere. If you cut the sphere in two, we have the hemisphere. So it means that the volume of this becomes half of the volume of a sphere, right? So it's half the volume of a sphere, which if you have this, we can just get 2/3 pi r cubed. That's how we can find the volume of a sphere and a hemisphere. And finding the total surface areas of this is also very simple. So let me just do like this. So if you're trying to find the total surface area of that, we just say 4 pi r squared. So we say 4 multiplied by pi, but the radius squared. But since we know that a hemisphere is half of that. So it means that the total surface area of the hemisphere becomes half of that, which will just give us 2 pi r squared. That's a total surface area of a hemisphere. Can you see that? Yes. So now we are done dealing with rectangular prism, triangular prism, and a sphere. So it means that I'll cut this video here, and then I'll do the last part that will be focusing on pyramids, cone, and also a cylinder. So if you've enjoyed up to so far, please show us by liking, subscribing, commenting, following our pages. You won't regret this. See you on the next one. Enjoy.